They say an ounce of prevention is worth a pound of cure. Now, I had a question on one of my YouTube videos, and someone asked basically, what is my take on healthcare post AGI? And I said, that is a great question. Let's unpack this. Now, pretty much the cornerstone of my view is, again, this saying that an ounce of prevention is worth a pound of cure, which basically means that the best health emergency or the best disease is the one that never happens. The optimal number of hospital visits in your entire life is 0. So how do we get to as close to 0 as possible? And this is also going to unpack why I have said in the past, why I think that hospitals as we know them could largely be a thing of the past within 20 years or so. So there's a few cardinal principles here. Number one is that AGI is going to absolutely revolutionize our approach to proactive healthcare. So that means, prevent aging, prevent diseases, prevent cancer, prevent chronic conditions, and that sort of thing. Now, right up front, I will admit there are a few things that we will absolutely need hospitals for, namely violence and trauma of all kinds. So like car accidents, if you're in if you fall off of a ladder, that sort of thing. But those are injuries, which are a very distinct kind of need for hospitals. What I think that we're going to get rid of are going to be age-related diseases, chronic diseases, cancers, infectious diseases, and those sorts of things. And so the primary intervention of healthcare is going to be mostly prevention. So that means early detection and early treatment. So let's unpack these one category at a time. So the first category is preventing aging. As longevity researchers like Aubrey de Grey have said, if you think of aging as a disease, aging is the greatest single risk factor to health. Why? Because the older you are, the higher risk you have of Alzheimer's, cardiovascular disease, cancer, all that other fun stuff. Well, fun, you get it, what I mean. So the goal then is if you treat aging like a disease and you try and prevent it, and you can either halt aging or reverse it. So there's anti-aging, which just says, hey, let's stop aging in its tracks. This is things like metformin and intermittent fasting and a few other things. These don't generally cause rejuvenation. And so the rejuvenation, though, is returning your biological clock to a younger state. So really the goal should be rejuvenation therapy, not just anti-aging and not just regenerative medicine, but rejuvenation. So rejuvenation literally means a return to youth. If you hear me use rejuvenation, that's why, because that's really the goal. If you agree with this, then you should have a goal of like your biological clock should be around 18 to 20 or whatever, kind of when you reached full maturity, and then you want to stay there. This is going to make you more physically robust against injuries. It's going to reduce risk factors for all kinds of chronic and age-related diseases. Now, not all of them, and we'll unpack that in just a moment, but when you look at what AI is capable of today, AlphaFold to the fact that ChatGPT and these other things can read massive amounts of papers, and then we're just at the beginning of this curve in terms of multimodal models and other specialized models that can help you simulate genetics, proteins, and that sort of thing. Preventing aging it's certainly on the horizon. There are a lot of problems associated with aging because it's not just telomeres, it's not just genetic damage, it's not just aging tissues. The human body is one of the most complex systems in the entire universe, and so it can break a lot of ways. Just kind of like your car, which is, many orders of magnitude simpler than the human body. There's any number of ways your car can break down. You can have the motor, the tires, the brakes, the electrical system, the fuel system. There's all these interrelated systems, and a problem in any one of them can cause the whole car to break down. Likewise, your body is a very complex set of interrelated systems, and a problem in one place can cause breakdowns of the whole system or in other places. Now, fortunately, we have 3.8 billion years of evolution behind us, so our systems are actually relatively robust and incredibly flexible. One of the reasons that I'm really confident that we can solve the problem of aging is because we already have a lot of mechanisms, a lot of metabolic and genetic mechanisms, and so I predict personally that rejuvenation therapies are probably going to come down to a few maybe mRNA vaccines, maybe monoclonal antibodies, and a few pills. Because if you activate the right genetic circuits, the right metabolic pathways, your body has the ability to regress itself. Now, will it be that easy? Will it be that cheap? I don't know. I have another video about the economics of this. So yeah, check that out if you want to understand like the role of government and policy and corporations and investments. But from a first principles scientific perspective, I don't know of any mechanisms that mean that it is physically impossible, like, the chemistry of it, the biology of it, the genetics of it. I don't know of anything that says that it is impossible to prevent or reverse aging. It's a difficult problem, but I don't see anything that says this is not possible. Converse to something like warp drive or teleportation, you can do some things, but the laws of physics are also working against you for some of these more fantastical things. But I don't know of any laws of physics that prevent biological immortality, or indefinite lifespan is the clinical term. So, number one, prevent aging, reverse aging. Number two is combating infectious disease. So, the rise of vaccines, the rise of antibiotics, that's viral and bacterial kind of stuff that we really had a revolution of over the last century. We don't have to worry about polio anymore. We can treat tuberculosis, which was once one of the major health concerns. We figured out how to, get rid of malaria and a whole bunch of other stuff. Now, with that being said, there are still infectious diseases on the rise. You probably hear on the news every now and then, like, another superbug has evolved, antibiotic resistance. And so we're constantly in this evolutionary arms race, because every time we throw a new antibiotic at it, eventually the staph bacteria or whatever evolves immunity to that antibiotic, to that medicine. What AGI is going to do is it's going to accelerate the timetables of our research. So will we be able to eradicate, harmful bacteria? No, it's physically impossible to eradicate Staphylococcus aureus. Why? Because it is part of our environment. It's part of our biology. But with AGI, we can accelerate the arms race and hopefully outpace those harmful strains. And it's also entirely possible that when you combine genetic sequencing with AGI and protein folding, that we can actually create medical interventions for infectious diseases that are targeted at very specific strains, which means that it might be very difficult for them to evolve immunity. And then even then, once they evolve immunity to that, you can find another molecule or another set of treatments that is able to attack that new version. We can also probably shape the evolution of those infectious pathogens. So what I mean by that is, this is a practice that hospitals already use, where they rotate through the kinds of sanitation protocols, the kinds of cleaners that they use, because they know that, okay, after 1 month or 6 months or whatever, pathogens tend to evolve a resistance to cleaner A, and so then we'll move to cleaner B, because then they have lost the immunity to that other one. So one of their superpowers is also an Achilles heel, which is that pathogens evolve very quickly. In the span of 6 months, they might go through several hundred or several thousand generations, which means that, hey, if they lost a selective pressure, then you can, shape them and kind of go back and forth. So that's one thing to keep in mind. So we've talked about preventing aging and combating infectious disease or pathogens. So the third kind of pillar that AGI will be able to help us with is halting chronic conditions. So chronic conditions are those that kind of accumulate over time, namely things like plaques in the brain and plaques in the arteries. And so, like, high cholesterol is something that I have. It's a genetic thing. So what happens is cholesterol accumulates in your arteries regardless of your age. And this is due to a broad number of factors. Now, fortunately, it's completely treatable and controllable, but as of right now, it's not necessarily reversible. So, like, I've halted the problem of high cholesterol, but it's not been reversed. We're also starting to find therapies that might halt or reverse the accumulation of, like, amyloid plaques, as in the case of Alzheimer's. But there's plenty of other chronic conditions out there, neurodegenerative diseases, other dementia risk factors like Lewy body syndrome, and those sorts of things. And these are substances, plaques, and chemicals that accumulate in the body over time, or damage that accumulates over time, irrespective of your biological age. And so chronic conditions like those neurodegenerative diseases, like those plaques, like those cholesterols, those are going to be an entirely separate class of treatments that are required. There has been a lot of news out there about nanoparticles being used. And so this is one kind of myth that I want to dispel. When people talk about nanotechnology and nanobots and that sort of thing, it's not just a robot that is much smaller. Nanotechnology is a fundamentally different approach. It's basically like you have several molecular machines that are stuck together. But these are not machines like in terms of levers and gears and that sort of thing. They're machines in the fact that they have, an enzyme, a protein, and, some other molecule kind of all stuck together, each that serves a particular function. But it's not just a small machine with a chainsaw that's going to go, like, cut up the cholesterol in your arteries. That's not exactly how it works. But there are nanoparticles out there that will tend to embed themselves, for instance, in cholesterol, and then will change the chemical composition of the cholesterol that then allows your immune system to then break it up and carry it away, that sort of thing. We can start to do that with mRNA vaccines, but certainly there are going to be substances that accumulate in the body that maybe your immune system can't get to. But then, a combination of empowering your own immune system to clean up these plaques and these chronic conditions in conjunction with these nanoparticles, this nanotechnology, will probably allow us to solve all of these problems eventually. Nanotech, however, is a very slow and expensive and often dangerous field to study. So the reason that nanotechnology can be dangerous to study is because the particles are so small, it gives them a very high surface area, and they're also highly reactive. And that their reactivity is by design. You want them to be chemically reactive, but if they react to the wrong things and you breathe it in, for instance, it might dissolve your lungs. Kind of like how, I don't want to say it like asbestos, because asbestos doesn't dissolve your lungs, but it does form small particulates that you can inhale, and then that causes cancer later on. So I know all this because a friend of mine studied material science back in college, and he's like, oh yeah, this stuff is super dangerous if you don't handle it right. Now, hopefully, AGI and maybe AlphaFold 3 will be able to help us design nanoparticles, that sort of thing. But yeah, so that's the first three categories. Let's use AGI to slow down and reverse aging. Let's use AGI to slow down and combat pathogens and infectious diseases. And then let's also use it to halt and reverse chronic conditions. And then finally, there's the trauma and accidents. So this might be one of the most persistent needs for hospitals and ambulances. You fall at home, you cut your arm open, you burn yourself on the stove, you get in a car accident, those sorts of things. But these are very particular kinds of injuries. And so you'll probably always need a trauma center. You'll probably always need, a birth center for, delivering babies and that sort of thing. But if you get rid of all three of these other categories, age-related diseases, infectious diseases, and chronic conditions, the need for hospitals and the need for doctor's visits is going to really just plummet. And so I have some ideas about how medicine is going to be deployed in the future. Particularly because wearables like this, they're getting more sophisticated all the time, to the point that if you see in the news, there's articles out there saying that AI can detect diabetes in your voice, or AI can detect Alzheimer's just by looking at your pupils, all kinds of stuff. And so I suspect that in the future, I don't know how soon, but at some point in the future, just looking at the webcam, the doctor might be entirely a machine, or it could be an app on your phone. It just says okay, here's your doctor app, hold the phone close to your eyes and then, wave it around or whatever, right? You'll basically have tricorders. That's the TLDR is we'll have Star Trek tricorders before too long that will be able to detect and diagnose pretty much anything with the help of AI. If you ever watched, Star Trek, Next Generation, and Dr. Crusher has the little probe that she waves over you, and then it's you have this, and this disease. That seemed like science fiction, but the combination of computer vision and everything else that's happening, the ability to read audio, the ability to rapidly sequence genes, this is becoming a real possibility. And so then your phone is probably going to be the primary source of information about your health, and it can be passively monitoring your health at all times. So you've got your phone, you've got your wearables. We might also have implants. I'm not so sure about that because usually implants are very invasive. And so it's usually much easier to read what's emitted from your body, like sweat and urine. Those sorts of things are very easy because your body naturally gives them off. Drawing a little bit of blood, there's people that test their blood all the time with, diabetics. So a really small finger prick, because there are over 2,500 substances in your blood. There's probably more than that. And there's different permutations of those substances, different ratios. You can get a lot of information about someone's health from their blood. It's been fascinating. Just over the last 10 years, the amount of blood that they need to draw for medical tests has gone down, and the amount of information that they can get from that blood has gone up. I think AGI is going to turn that up to 11. So imagine in the future, you wave your phone over your face and you take a drop of blood or even just a drop of sweat. And then you can get someone a full diagnosis. And this can detect internal problems too, because there's all kinds of things that happen depending on which organ is in distress or if you've got a tumor growing or whatever. So the technology, those kind of three vectors of implants, your phone, and wearables, I think means that you might never have to visit an actual doctor. I think that you'll be able to get high enough quality information within the next 5, 10, 20 years, certainly, that you might never have to go to an annual physical. Here's another example. You look at Meta and the Meta Quest, the VR headset, and the fact that they're able to like measure your gait just by your head motion on the headset. There's all kinds of information and telemetry that you can get. And so like even if you have a physical injury or a physical problem, it's like, hey, your stride has changed, so maybe you have a knee injury, right? Like your phone can probably detect knee injuries or hip injuries or back injuries with the right training and that sort of thing. So, you know, that level of data, that level of information that is already available, that's already being emitted by our bodies, all we need to do is pick up that information, and then what happens? So I suspect that you're going to have, you know, your health account. I know that Google and Amazon and Microsoft, they want to be your health provider. Put it this way, I'm never signing up for Amazon Health. That just sounds like a bad idea. But to their point, I think that the healthcare of the future is going to be mostly a tech company, and you're going to have a wearable, you're going to have an app on your phone. And what's going to happen is they're going to look at your genes, they're going to look at all the telemetry, all the test results, you know, and then what they'll do is they'll just send you a customized prescription, whether it's an injectable or a pill or whatever. They might say, hey, go to your local pharmacy. We've got the, you know, the test ordered up. We've got the medicine ordered up. Your pharmacist will, you know, administer it, and away you go. And so then, you know, you're going to have a few pills, a few injections. Not a whole lot is going to go into your health maintenance in the future because, again, an ounce of prevention is worth a pound of cure. And so it's much easier to prevent things before they get bad. Now, there is also one elephant in the room that I need to address, and that is the fact that depending on which, like if you look at ICD-10 or ICD-11, there's something like 17,000 diagnosed and documented diseases, and even within those diseases and injuries and ailments, there's many versions and permutations on top of your genetics, on top of your microbiome. And so there are literally thousands, tens of thousands of documented but untreated diseases. And so only a relatively small fraction, I think it's like, again, it depends on how you count because how you define a disease is difficult, but it's anywhere from like 1% to maybe 20% of diseases are even treatable and fewer are even curable. And so we're kind of still living in the dark ages in terms of medicine because it's like, well, you know, we have to rely on your biology to take care of it and we just kind of support the symptoms and you do the best that you can. You see this on Twitter, on LinkedIn, on YouTube. I see it in the comments where people talk about like, yeah, I'm living with a chronic condition. It's not treatable. It's not curable. You just do the best that you can to mitigate the symptoms. It's very palliative. So that's what's called palliative care, where you just reduce the symptoms, but you don't treat the underlying cause. So one of the biggest things that I'm hoping for with AGI is that percentage goes from 1% to 100%. You know, like I said, the optimal number of hospital visits in your lifetime is 0. Let's get as close to that as possible. But also the optimal number of diseases treated or preventable or curable is 100%. We're nowhere near 100% curable diseases right now. AGI is necessary. That amount of cognitive surplus, that cognitive hyperabundance is necessary to get to 100% coverage of all diseases. That's personally one of the reasons that I do what I do. So you might be wondering, and as we'll close out the video, how can you help? How can we get there? So there's a few problems. One, learn and pursue AI careers. Just learn everything that you can about AI. Yes, we're still in kind of the early phase. You know, we have language models that are just kind of past the threshold of being useful. We've got image generators, we've got generative AI, we've got AlphaFold. There's all kinds of stuff that you can do to learn about and use AI and pursue a career, any career in AI. Because the number of people that we need to be experts in AI is here. The number of people that are experts in AI is here. And so yes, I'm the one who's always talking about post-labor economics, but we're not there yet. And until we are past that threshold where AI is smarter than all people and can help making the AI better, we need more human brains working on AI. If you don't have a career in AI, you can at least teach it. You get on YouTube, LinkedIn, whatever. Help people learn prompt engineering, help people learn loss functions, building neural networks, curating data sets, that sort of stuff. If you can teach someone, that is just as valuable. And personally, I would recommend go to the most scalable places that you can teach. TikTok, YouTube, LinkedIn, Facebook, what Instagram, whatever. Just like use an exponential platform that has global reach, and that's why I chose YouTube. That's literally why I'm here right now, is because YouTube has a global reach. It's got 2 billion users. So it's like, hey, the blast radius of any idea that I put out there is really big. Promote AI. So one of the biggest things is promoting AI in industry and in politics. Vote with AI in mind. Choose politicians who are bullish on AI, but also advocate inside industries because, for instance, you're going to see a lot of friction and a lot of resistance, which is there for a reason, because right now AI is not guaranteed to be better than all humans, but you need to advocate for those experiments. You don't know until you try it. And so then you can also support those regulatory reforms, again, by voting, by advocating to say, hey, we need to get as much AI into the healthcare and medicine space as possible and as soon as possible, as soon as it's safe and reliable. But again, there's a lot of red tape, there's a lot of friction, and so that is honestly probably the hardest work. Overcoming the regulatory hurdles is probably the hardest work. So anyways, thanks for watching. I hope you like this video. Let's build a future where there are no diseases, there is no unnecessary or premature death. I think that it's within the realm of possibilities. I really want my healthcare visits to be as easy as it is. You go to sickbay, Crusher waves a tricorder over you, gives you a hypo spray, and you're on your way. That's honestly, I think, probably the best model as to how healthcare is going to look in the future. Cheers.